Hi, welcome to this lesson on Probability Counting Principles Part 1. Let's have a look at example 3. So this is a very nice example because now it uses the fundamental counting principle with what we call grouped objects. So objects that can be grouped together and considered one singular object. So there are 2 different history books, 2 different geography books, 3 different English books, and 3 different technology books all sitting on a shelf. In how many ways can they be arranged if the books can stand next to each other in any given order? Okay, so first of all, there are 2, 2, 3, and 3 books altogether. So there are 10 different books. So by the fundamental counting principle, if any book can go in any position, then there are 10 factorial or 3,628,800 different ways we can arrange those 10 books to stand next to each other on the shelf. But what if all the books of the same subject must stand next to each other? So here now we have a classical example of grouping objects together to be considered their own object. So we must have that all the history books must stand next to each other, all the geography books must stand next to each other, all the English books and all the technology books must stand next to each other. So I've labeled them as H, G, E, and T for the subject, and then the subscript 1, 2, and 3 to denote either the first book, second book, or third book. So essentially, there are 4 different objects, okay? So you can think of the 2 history books together being one object, the 2 geography books together being one object, the 3 English books together as one object, and the 3 technology books together as one object. So how many ways can you arrange these 4 objects? Well, there are 4 factorial ways to arrange them. But can you see in each object, there are sub-objects. So there are 2 objects in this one, 2 objects in that one, 3 objects in that one, and 3 objects in that one. So those objects can also be arranged within each other. So there's a 2-layer deep way that we can change these objects, arrange them within each other. So essentially, for the first one, there are 2 factorial ways to arrange these 2 books in that one object. 2 factorial ways here, 3 factorial ways here, and 3 factorial ways here. So by the fundamental counting principle, how many total number of different arrangements are there? Well, there are these 2 factorial, these 2 factorial, these 3 factorial, and these 3 factorial that can be arranged within each object. So these are the sub-objects. And all of these 4 main objects can also be arranged in 4 factorial ways. So by the fundamental counting principle, there are 4 factorial times 2 factorial times 2 factorial times 3 factorial times 3 factorial. So let's bring up our calculator and check what that gives us. Okay, so we have 4 factorial times the 2 factorial. No, let's go back 1. Okay, so 2 factorial times the 2 factorial times the 3 factorial, okay, and then lastly times another 3 factorial. So putting all that together, we get 3,456 ways that we can arrange those books such that these books of the same subject are always next to each other, and then also those books of each subject can also be arranged in their multiple ways. How many different ways can there be if the English books must be next to each other? Okay, so as I've said previously with these types of problems, these are very logical word problems. So let us use logic to work out how many arrangements there are if all 3 English books must be next to each other, because there were 3 English books. So let's see. Well, first of all, let's recall how many total books were there. There were 10. So let's say, for example, the 3 English books were here. And then there were 1, 2, 3, 4, 5, 6, 7 different spaces here for all the other books. So the other 3 technology books, the other 2 English, other 2, what were the other 2 subjects here? History and geography. Okay, so there was history, geography, technology, and English. Okay, so over here there would be 7 factorial ways. But also here in these 3 objects, there are 3 factorial ways of arranging those 3 English books, but they are still next to each other. Now let's imagine in the shelf, we just move them over one slot. So now one book can go here, and the other 6 can go here. So there's still a total of 7 factorial ways for those blank spaces, and still 3 factorial ways for the English books. And we can keep moving the 3 English books one spot over and over until we get up to the last spot here, okay? And then a final way is just putting them all next to each other and then having the 7 spots. Okay, so how many ways are there? There's 1, 2, 3, 4, 5, 6, 7, and an 8th way. An 8th way here. 3 factorial times 7 factorial. Okay, so in total, there were 8 amounts of those 3 factorial times 7 factorials. Okay, and we can write it like this. So what I'm going to do is because multiplication is commutative, I can say 3 factorial times 8 times 7 factorial. And the reason why I want to do that is because 8 times 7 factorial is just 8 factorial. Okay, because that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so we have 3 factorial times 8 factorial. So if we put that into our calculator, what do we get? 3 factorial times 8 factorial. That gives us 241,920 ways to arrange the books, such that all 3 English books stand next to each other. So another way you can think about this is that there are 3 factorial ways to arrange the English books, and there are 8 spaces that the 3 English books can be arranged within the remaining 7 other books. And that's exactly the sort of thinking that we did here. There were 8 possible spacings that could happen. 2, 4, 5, 6, 7, 8. So therefore, there's a total number of 8 factorial of those spaces times the 3 arrangements. So if you can count the number of spaces that you can have between the objects, then that number factorial times the number of ways to arrange the objects will give you the same solution. Okay, but like I said before, in these types of examples, when it comes to counting principles, you're going to want to be able to use your logical word problem solving skills to help you visualize what is going on here and then how to count the objects. All right, I'll see you in the next one.